Topic 6, Part 3, Standard enthalpy change of neutralization. Learning objectives: be able to define standard enthalpy change of neutralization, understand simple experiments to measure enthalpy change in terms of evaluating sources of error and assumptions made in the experiments. Be able to process results from experiments to calculate a value for the enthalpy change of neutralization. Enthalpy change of neutralization can be defined as the enthalpy change measured at 100 kilopascals at a temperature of 298 Kelvin when 1 mole of water is produced by neutralization of an acid with an alkali. The ionic equation is usually hydrogen ion plus hydroxyl ions to give us water. Using a worked example, let's get to understand how we can calculate enthalpy change of neutralization. Given that the volume of hydrochloric acid is 25, volume of sodium hydroxide is 25, initial temperature of the acid is 18.6, initial temperature of alkali is 18.8 degrees Celsius, and the maximum reached temperature is 298.5 Kelvin. The mean starting temperature will be temperature of the acid plus the temperature of the alkali divided by 2. Then the temperature change will be obtained by the final temperature minus the mean temperature. The volume of the solution will be the addition of the acid and the alkali. The mass of the solution will be 50 grams because we will assume that the density of the solution is 1 gram per cubic centimeter. Now, using the formula Q is equals to MC, change in temperature, or delta T, we input our values and we will get our Q, or heat energy, as 1400.3 joules. So we convert that to kilojoules. A reminder, 1 kilojoule is equals to 1000 joules. From there we calculate the number of moles of water, which we will get our answer as 0.025 moles. Now, using the formula of finding the enthalpy, which is change in H, delta H is equals to negative Q, which is our heat energy, divided by number of moles, which is N. Now, our Q is 1.4003 kilojoule. Our number of moles, or N, of water is equals to 0.025 moles. So, negative 1.4003 divided by 0.025 will give us our enthalpy change of neutralization, which will be equals to negative 56 kilojoule per mole. A review of the learning objectives: be able to define standard enthalpy of neutralization, understand simple experiments to measure enthalpy change in terms of evaluating sources of error and assumptions. Now, just a reminder, some of the sources of errors here is energy loss. The assumption that we make is that the solution or the reacting solutions will have a density of 1 gram per cubic centimeter. Be able to process results from experiments to calculate a value for the enthalpy change of neutralization. That is part 3. Thank you.